Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is number-based system. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external or entrance examinations into high school, this topic, this lesson is for you. Lesson 4, conversion of fraction in other bases to base 10. From lesson 2, we learned that whenever you are converting from other bases to base 10, whether the number is a whole number or fractional, the approaches are continuous multiplication by power expansion and extended multiplication. Examples: express the following in denary base. You know, denary base is also decimal base, which means base 10. Example 17. We have this number 10101.0001. The given base or the given digits indicate base 2. Base 2, that is, yes, that is base 2, binary base. And you know, when we are converting to base 10 like this, first thing we do is to assign the position value or place value to each digit. After doing that, you multiply each digit by the base number 2 and you assign the position value, or you attach it to the base number. This number is decimal, so to assign the position value from the point to the left, you have positive. From the point to the right, you have negative. So for the first one, before the point, you have 0 followed by 1. This is 2. The next is 3 followed by the last digit position is 4. From the point to the right, the first digit is -1, the second is -2, the third is -3, and the last is -4. After doing that, you multiply each digit by base 2 and attach the power to the base number. So we have 1 times 2 base power 4 plus 0 times 2 power 3 plus 1 times 2 power 2 plus 0 times 2 power 1 plus 1 times 2 power 0. We are now in the decimal part, so you have 0 times 2 power of -1, 0 times 2 power of -2, 0 times 3 power of -3, 0 times 2 power of -3 plus 1 times 2 power of -4. All the terms that you multiply by 0, they are 0 instantly, so we are left with the other terms. That is this will be evaluated. We have this also, this will be evaluated, and this. So 2 power 4 here is 16. 16 times 1, we have 16, followed by plus 0. 2 power 2 is 4. 4 times 1, you have 4, then plus 0. 2 power 0 is 1. 1 times 1, you have this 1 here. So you have plus 0, plus 0, plus 0 until you get here. First, we have to change this number from decimal, from negative power, and that is writing it in inverse form, where you have 1 multiplied by 1 over 2 to the power of 4 is expressed in this form. So 1 times 1 is this 1 you have here. 2 power 4 is 16. So you add together the whole number part, that is 16 plus 4, that is 20, plus 1, you have 21, plus the fraction. When put together, you have 21 whole number 1 over 16 in base 10. In base 10. Example 18, you have 0.765 base 8. You should convert it to base 10. The same approach. The position of 0 here is 0. From the point to the right, we have minus 1, minus 2, and minus 3. You multiply each digit by the base number 8, and you attach the position value to 8. So you have 0 times 8 power 0 plus the right side of the point. You have 7 times 8 power of minus 1 plus 6 times 8 power of minus 2 plus 5 times 8 power of minus 3. The first term is 0. So like I explained here, you express this as 7 times 1 over 8, and that is 7 over 8. You express this as 6 times 1 over 8 square. So 6 times 1, you have this 6 here. 8 square is 64. You express this as 5 times 1 over 8 cube. 8 cube is 512. 5 times 1 is 5, so you have 5 over 512. This is fraction addition. You find the LCM of 8, 64, and 512, and that is 512. The rule is that you divide the LCM by each denominator, your answer times numerator. If you divide 512 by the denominator 8, you have 64 multiplied by numerator 7. The same 512 divided by 64, you have 8 times numerator 6. Divide the LCM by the last denominator 512, you have 1 times numerator 5. When you multiply out, you have 448 plus 48 plus 5 over 512. And when you add the numerator, you have 501 over 512. Then you write it to base 10. So the only difference here is that we have two sets of position values. The one to the left, which are positive, and the one to the right of the point, which are negative. The same continuous multiplication by power expansion is being used. Hello. Example 19, you have 20.415 base 8. This is the given number. you assign the position where this is 0, this is 1. To the right, you have -1 followed by -2 and -3. So you multiply each digit by 8, attaching the position value to the base. So you have 2 times 8 power 1 plus 0 times 8 power 0 plus 4 times 8 power of -1. We are now in the decimal part. 1 times 8 power of -2 plus 5 times 8 power of -3. If you simplify this, 8 power 1 is 8 times 2 is 16. 0 times 8 power 0 is 0. Then you write this as 4. Okay, so there for you 4 times. You convert 8 power 1 to 1/8. Then plus 1 times 8 power of -2 as 1/8 square, that is 64, plus 5 times 8 power of -3 as 1/8 cube, and that is 1/512. So when you multiply out, you have 16 plus 4/8, that is, multiply 4 by 1 now, you have 4/8 plus 1/64 plus 5/512. That is 5 times 1 is 5 over the denominator 512. So you have one whole number part, that is 16. When you add all the fractions together, as I explained in the last example, you have 269 over 512. When you add the whole number to the fractional part, you have a mixed fraction, that is 16 whole number 269 over 512 in base 10. Example 20, you have 0.1013 base 5. So this is the given number. Position of 0 before the point is 0. To the right, you have negative position, starting with -1 for 1, then -2 for 0, -3 for the second one, and -4 for 3. So you multiply each digit by 5 and you attach the position value to the base. So we have 0 times 5 power 0 plus 1 times 5 power of -1. We are now in the decimal part, plus 0 times 5 power of -2 plus 1 times 5 power of -3 plus 3 times 5 power of -4. This term is 0, that is what you have here. This is 1/5. You express this as 1 times 1/5. So you have 1/5. This term is 0, that is what you have here. You express this as 1 times 1/5 to the power of 3, and that is 1/125. That is what you have here. You express this as 3 times 1/5 to the power of 4. 3 times 1 is 3. 5 power 4 is 625. That is what you have here. So when you add the 3 fractions together, you have 133 over 625 base 10. Base 10. Are you following? Example 21, you have 3a.1e base 16. The same thing we are doing. First, you assign the position value to each digit, then you multiply by base 16 and you attach the respective position. From the point to the left, you have positive, so a is 0, 3 is 1, 1 is minus 1, then e is minus 2. So we have 3 times 16 power 1 plus a times 16 power 0. If you move to the decimal part, you have plus 1 times 16 power of minus 1 plus e times 16 to the power of minus 2. In base 16, it is clear that a is equal to 10 and e is equal to 14. So you write the same expression, but you replace a with 10 and e with 14. Then you continue to simplify. Here, 16 power 1 is 16 times 3. You have 48. 16 power 0 is 1 times 10. You have 10. You express this as 1 times 1 over 16, and that is 1 over 16. You express this as 14 times 1 over 16 square. 14 times 1 is 14. 16 square is 256. The whole number part, when added, 48 plus 10, that is 58. If you add the two fractions, you have 30 over 256. If you add the whole number and the proper fraction, you have a mixed fraction. But you can reduce 30 and 256 by 2 for you to have 15 over 128. So you have 58 whole number, 15 over 128 in base 10. Hello. Example 22. Express 1 over 8.9 base 10 as a decimal, showing the first 8 digits after the decimal point. Okay, so if you divide this number, you have many digits, but the first 8 digits are this. So the given base is base 10, and we should express it as decimal. So as you know, if you attach the position value, this will be 0. Here you start from minus 1 and you end with minus 8. So you multiply each digit by 10, and you attach the position value. So you have 0 times 10 power of 0 plus 1 times 10 power of minus 1 plus 1 times 10 power of minus 2 plus 2 times 10 power of minus 3 plus 3 times 10 power of minus 4 plus 5 times 10 power of minus 5 plus 6 times 10 plus 9 times 10 power of minus 6 plus 5 times 10 power of minus 7 plus 5 times 10 again power of minus 8. So you have the first 8 digits. So the first term is 0, so you express this as 1 over 10 in this form. This 1 times 1 over 10 square, that is 1 over 100. 3, this is 2 times 1 over 10 cube, that is 2 over 1000. 3 times 1 over 10 power 4, that is 3 over 10,000. Then you express other as well, and you have this result. Now if you divide this place, you have 0.1. Here you have 0.01. Here you have 0.002. So when you divide like that and you add, you have 0.11235. Matter of fact, what we have is the same as what you have here. So this is how you convert fractions from other bases to base 10. Hello. End of lesson 4. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not safe, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.